Hey everybody, today is going to be a very short video on scientific measuring or measuring, whatever you want to call it. We're going to focus on how to actually properly measure things in science. We're not just going to randomly choose a number when we're kind of close with a ruler or kind of close with a graduated cylinder, whatever we're measuring with. We're going to try to be as scientifically accurate and as scientifically precise as possible. So normally, when you have measured things in the past, this is what you might have done, what the general public tends to do. "180 centimeters, that's how tall I am." Exciting. Look, that's all fine if you're just looking for a rough height for someone, like I'm about 180 centimeters, based on my 2-meter sticks that are taped to my wall. But that is not a good scientific measurement. That is actually a trash measurement. We're going to look at today how to measure precisely in the lab, and it's actually very easy. It just requires you to get really up close and personal with the measuring tool that you are using. Okay? Let's get to it. All right, so when you are measuring, whether it's with a ruler, a graduated cylinder, a thermometer, anything, you need to focus on a few things. Number one, I guess I'm going to focus on the ruler first. You need to know what the increments are for your measuring device. So what we're going to do in science is focus on the metric system. So we're going to look at centimeters in this case. So for my ruler, note that my centimeters, we got, there's 2 centimeters, 3 centimeters, 4 centimeters, whatever. In between we have the little increments here. These are millimeters, but I like to use decimals. So here we have 3 centimeters. That's, 3.1, 3.2, etc. So pretty much my ruler goes by 0.1 centimeters. So if I measure something, I know for a fact if something is over 3.1 or over 3.2 centimeters. Okay? So what I'm going to do is measure a Post-it note, and here's an image of it since I can't get it too close. So what we're seeing with the Post-it note is that the size of the Post-it note, or the width, length, whatever you want to call it, is over 7 inches for sure. 7 centimeters for sure. It's over 7.5. You can see that it's over 7.5 right halfway. It is not quite to 7.6. Okay? This is actually crucial because in a precise scientific measurement, you only need to include the digits that you know are 100% correct plus an estimated digit. All right? You have to estimate a single digit for every single scientific measurement that you take. So for the Post-it note, it's over 7.5, but it's not quite yet to 7.6 centimeters. So my measurement, I'm going to try to get as close as I can. If it's between 7.5 and 7.6, I'm going to call it 7.58 centimeters. That is my measurement. All right? I can't leave it at 7.5 because I know for a fact it's over 7.5. I can't put it at 7.6 because it's not there yet. I'm just lying to myself. That's garbage, okay? So it's between 7.5 and 7.6. Therefore, my measurement is 7.58. That final 8 is an estimated digit, and every scientific measurement needs that. It is not challenging to do because you're just estimating a digit. So you're not lying to yourself when you're writing down your measurement. If you just write down 7.5, that's garbage because you know it's more than 7.5. So you got to write down 7.5 something. So 7.58 is my measurement. All right, so that's length. Let's take a look at graduated cylinders. So I'm going to try to show you this as best as I can. But graduated cylinders, all right, they are used to measure volume. There we go. They're used to measure volume. I'm very shaky, so I'm going to try to keep it as steady as possible. What you are seeing here is that you see that little dip? There we go. That little dip is natural with graduated cylinders. No big deal. You've probably heard of it before. It's called a meniscus. All right. Sorry, I'm all shaky. The meniscus basically is formed from water creeping up, or liquid creeping up the edge of the cylinder. You can't stop it. All right. The best way to measure graduated cylinder volume is to measure from the bottom of the curved part. All right. So again, I'm going to put an image up here of this same cylinder, and we are going to measure the volume. All right. So the same thing is with the ruler. You need to figure out the increments for your cylinder. So for this cylinder, we're seeing that it goes up by ones, which is kind of nice. So we're going to look at the bottom of the meniscus, so the lowest point of that curve. And so for this one, if we count up, you can see that we are right between 27 and 28 milliliters. Okay? So if you write that this measurement is 27 milliliters, you are lying, because it is over 27 milliliters. If you write that it's 28 milliliters, that is also wrong, because it is not yet there. It's not there yet. So your measurement is in between 27 and 28 milliliters. Therefore, that's when you estimate the digit. And it looks to be pretty much right between the two, so I'm going to write 27.5 milliliters. Normally, if I'm not quite sure if it's right between the two numbers, I'm going to estimate a 5 because it looks to be pretty much right in the middle. But that is up to you. That's up to the scientist. Is it closer to 27 or is it closer to 28 or is it right in the middle? So again, every scientific measurement requires you to know the increments of your measuring device. It requires you to write down all the known digits. And finally, you end it with an estimated digit, and you are done. Oh, don't forget the unit. Chemistry teachers love to include units on all their measurements. Okay, great. Thanks for watching.